In this video, we will practice solving trig equations. This is AP Precalculus topic 3.10. If you appreciate this content, please give it a like. Number 17, we again must find the x-coordinates of the intersection points between f and g. So we set the two functions equal to each other and solve. We must isolate the tangent function, so subtracting 3 from both sides gives us the square root of 3 times the tangent x is equal to 1. Now, dividing both sides by radical 3 gives us the tangent of x is equal to 1 over radical 3. We can find the reference angle by asking ourselves the tangent of what angle is equal to 1 over radical 3. We have memorized that the tangent of pi over 6 is 1 over radical 3. So that means the reference angle is pi over 6. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 6. We know tangent to be the slope of the terminal side. And since we want tangent to equal positive 1 over radical 3, we will stick to quadrants 1 and 3, where the slope and thus the tangent function will be positive. We can think of pi as 6 pi over 6. Therefore, this angle in the third quadrant is 7 pi over 6. We can think of 2 pi. Well, no, in the first quadrant, the angle with a reference angle of pi over 6 is pi over 6 itself. So these are the x-coordinates of the two intersection points. Number 18, the function g is given by g of x equals 2 minus 4 times the cosine squared of x. What are the zeros of g on the interval from 0 to 2 pi? The zeros of g are where g of x is equal to 0. So we just need to set function g equal to 0 and solve. Isolating the cosine squared begins with subtracting 2 from both sides. So that gives negative 4 cosine squared x is equal to negative 2. Next, we divide both sides by negative 4. Negative 2 divided by negative 4 is positive 1/2. So we have cosine squared x is equal to positive 1/2. Taking the square root of both sides, we get the cosine of x is equal to. When you take the square root of a fraction, you take the square root of the numerator and the denominator separately. The square root of 1 is just 1, so we end up with 1 over radical 2. Don't forget, when you take the square root of both sides of an equation, the solution is positive or negative. We can determine the reference angle by ignoring the plus or minus and asking ourselves the cosine of what is equal to 1 over radical 2. We have memorized that the cosine of pi over 4 is 1 over radical 2, so pi over 4 is the reference angle. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 4. Since cosine is allowed to be positive or negative this time, we will find solutions in all four quadrants. The angle in the first quadrant with a reference angle of pi over 4 is pi over 4 itself. We can think of pi as 4 pi over 4. So this angle in the second quadrant is 3 pi over 4. And this angle in the third quadrant is 5 pi over 4. We can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant is 7 pi over 4. So these are the four x-coordinates of the intersection points. Number 19, the function h is given by h of x equals 2 times sine squared x plus sine x. What are the zeros of h on the interval from 0 to 2 pi? The zeros of h are where h of x is equal to 0. So let's set h of x equal to 0 and solve. We need to factor out the GCF of sine x to get started. So I'm going to pull sine x outside of parentheses, dividing each term by sine x. The first term on the inside will be 2 times the sine of x. Sine x divided by sine x is 1. Next, we use the zero product property. We find solutions by setting each one of these factors equal to 0. So we will get solutions by setting sine x equal to 0 and by setting 2 sine x plus 1 equal to 0. Sine is the y value on the unit circle, and right here the y value is 0. Here the y value is 1. The y value is 0 again here, and the y value is -1 here. We are looking for the angle where sine, the y value, is equal to 0. So that's this first angle right at the beginning where x is equal to 0 radians because we haven't rotated anywhere yet. But it's also right here in this position. This is pi radians. So sine x will equal 0 at x equals 0 and x equals pi. Now let's solve the second equation. Begin by subtracting 1 from both sides. So we have 2 sine x is equal to -1. Dividing both sides by 2, we get sine x is equal to -1/2. We can determine the reference angle by ignoring the negative sign and asking ourselves the sine of what is equal to 1/2. We have memorized that the sine of pi over 6 is 1/2. So the reference angle is pi over 6. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since we want sine to equal -1/2, we will stick to the third quadrant and the fourth quadrant, where the y value, and thus the sine function, is negative. We can think of pi as being 6 pi over 6. Therefore, this angle in the third quadrant is 7 pi over 6. We can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. These are the 4 zeros of h on the interval from 0 to 2 pi. Number 20. What are all values of theta on the interval from 0 to 2 pi where cosine squared theta is equal to cosine theta plus 2? We begin by getting 0 on one side. So subtracting cosine theta and 2 from both sides, we get cosine squared theta minus cosine theta minus 2 is equal to 0. This is probably factorable. Cosine squared theta is going to be cosine theta times cosine theta. Now I look at the 2. I'm ignoring the negative sign for now. The only way to multiply and get 2 is if I do 1 times 2. Then I'm thinking inner plus outer must equal the middle. Inner is the product of these two, so that's 1 cosine theta. Outer is the product of these two, so that's 2 cosine theta. Inner plus outer must equal the middle, and the middle is this term right here. So the middle is my negative 1 cosine theta. So what do the sines of the inner and the outer need to be so that I get a negative 1 cosine theta? If I have positive 1 cosine theta inner and a negative 2 cosine theta outer, then I will get a negative 1 cosine theta for the middle. So that's how I know what the sines need to be. Also, always double check that you are getting the correct sign on the constant. In this case, positive 1 times negative 2 does give us negative 2, so it makes sense. So I usually do that part in my head, so I'm going to erase this. Now we use the zero product property, which says if we have two factors multiplied together and equal to 0, we can get solutions by setting each one of these factors equal to 0. Setting cosine theta plus 1 equal to 0, I get cosine theta is equal to negative 1. Setting cosine theta minus 2 equal to 0, I get cosine theta is equal to 2. There will be no solution on this side because long ago we learned that cosine has a maximum value of 1 and a minimum value of negative 1. So the graph of cosine sort of went like this, and it had a high of 1 and a low of negative 1. So there's no way that cosine will ever reach a value of 2. Or another way to think about it is that cosine is the x value on this unit circle. And these x values go from an extreme of 1 on the right and to an extreme of negative 1 on the left. We're sort of trapped on the unit circle. So the x values cannot get any further to the right than 1 or any further to the left than negative 1. So there's no way to get an x value or a cosine of 2. So no solution here. Meanwhile, I sort of answered this first equation with this picture. Where does cosine equal negative 1? Well, we see that cosine will be negative 1 right here at pi. So theta is equal to pi. That's it. On the interval from 0 to 2 pi, this is the only solution to this equation. Number 21. Let f of x equal 2 sine squared x and g of x equals negative radical 2 sine x. In the xy plane, what are the x-coordinates of the points of intersection of the graph of f and g on the interval from 0 to 2 pi? So we need to set these two functions equal to each other and solve. We have 2 sine squared x is equal to negative radical 2 sine x. When you have trig functions on both sides of the equation, you need to put both terms on one side of the equation and leave it all set equal to 0. Do not try to divide both sides by sine x. You will lose solutions if you do that. Instead, we are going to add radical 2 sine x to both sides of this equation. So on the next line, we will have 2 sine squared x plus radical 2 sine x is equal to 0. Now, that sine x that we were tempted to divide by is now the GCF. So that's how you handle it. You factor out a GCF of sine x. So I can figure out what will go inside the parentheses by dividing each one of these terms by sine x. If I divide this first term by sine x, one of the sines will cancel, leaving behind 2 sine x. If I divide this term by sine x, the sine x will cancel out, leaving behind the plus radical 2 part. Now I can do the zero product property, setting each one of these factors equal to 0. So I will have sine x equals 0 and 2 sine x plus radical 2 is equal to 0. Sine x equals 0 is ready to solve, but we need to do a little bit more algebra on the second equation. Subtracting radical 2 from both sides and simultaneously dividing by 2 will leave us with sine x is equal to negative radical 2 over 2. The solution to sine x equals 0 is going to be a quadrantal angle falling right on the x or y axis. So where does the sine equal 0? Sine is the y value on the unit circle, and y values are equal to 0 right here at the beginning, which is at 0 radians, and also again over here on the left. So right at the beginning, like I said, this is 0 radians, so we have x is equal to 0, but then over here this is at pi radians, so x is also equal to pi. Up here at the top the y value is 1, down here at the bottom it's negative 1, but we were looking for where sine is equal to 0, so that's here and here. Now, to find the reference angle for the second equation, we can ignore the negative sign and ask ourselves the sine of what is radical 2 over 2. We have memorized that the sine of pi over 4 is radical 2 over 2. That means that the reference angle is pi over 4. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 4. In this case, we want sine to equal negative radical 2 over 2. So we will stick to the third and fourth quadrant, where the y value, and thus the sine function, is negative. We can think of pi as 4 pi over 4. So this angle in the third quadrant will be 5 pi over 4. So that's a third solution. Doubling this, we can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant is 7 pi over 4. These are the 4 x-coordinates of the intersections between f and g on the interval between 0 and 2 pi. For number 22, we are again looking for the x-coordinates of the points of intersection between f and g. So we begin by setting the functions f and g equal to each other and solving. We have 4 cosine cubed x is equal to 3 cosine x. By now we know not to try to divide both sides by cosine x. Dividing by cosine will make us lose one of the solutions. Instead, we subtract. Let's subtract 3 cosine x from both sides, which gives us 4 cosine cubed x minus 3 cosine x is equal to 0. Now, that cosine that we kind of wanted to divide by is now the GCF on the left side of the equation. So we factor out a GCF of cosine x, the common factor. That will leave behind 4 cosine squared x minus 3 is equal to 0. We figure out what goes inside the parentheses by dividing each term by cosine x. Now we use the zero product property and set each one of these factors equal to 0. So we will have cosine x is equal to 0, and we will have 4 cosine squared x minus 3 is equal to 0. Adding 3 to both sides and dividing by 4 gives us cosine squared x is equal to 3 over 4. Taking the square root of both sides gives us the cosine of x is equal to. Don't forget, when you take the square root of both sides, the solution can be plus or minus. So we need to say plus or minus. When you take the square root of a fraction, you take the square root of the numerator and the denominator separately. So the square root of the numerator is radical 3. not much we can do with that. But the square root of the denominator is 2. So we get cosine x is equal to plus or minus radical 3 over 2. We can easily solve cosine x equals 0. Cosine is the x value on the unit circle. So where do x values equal 0? That's going to be here and here. On the right hand side, the x value is positive 1, and on the left hand side, the x value is negative 1. But cosine will equal 0 at pi over 2, which is right here. So that's one solution. And x equals 3 pi over 2, which is right here. So that is our second solution. When we look at cosine x equals plus or minus radical 3 over 2, we can determine the reference angle by ignoring the plus or minus and asking ourselves the cosine of what is radical 3 over 2. We have memorized that the cosine of pi over 6 is radical 3 over 2. That means pi over 6 is the reference angle for this equation. On the interval from 0 to 2 pi, here are the 4 angles with a reference angle of pi over 6. Since, in this case, cosine can be positive or negative, we will find solutions in all 4 quadrants. So, the angle in the first quadrant with a reference angle of pi over 6 is pi over 6 itself. The angle in the second quadrant with a reference angle of pi over 6, well, let's see. We can think of pi as 6 pi over 6. So this angle in the second quadrant is 5 pi over 6. The angle in the third quadrant is 7 pi over 6. Doubling this, we can think of 2 pi as 12 pi over 6. So this angle in the fourth quadrant is 11 pi over 6. So these are the x-coordinates of the 6 intersection points of the two functions on the interval from 0 to 2 pi. 23. Let f of x equal tangent squared x and g of x equals negative tangent x. In the xy plane, what are the x-coordinates of the points of intersection of the graph of f and g on the interval from 0 to 2 pi? So once again, to find the intersection points, we set the two functions equal to one another, and we solve. We definitely know not to divide both sides by tangent x, or negative tangent x. We will lose one of the solutions if we do that. Instead, we get 0 on one side by adding tangent x to both sides. That will give us tangent squared x plus tangent x is equal to 0. So instead of simply dividing by tangent, we factor out a GCF of tangent x. So tangent x goes outside the parentheses, and to figure out what goes inside the parentheses, we divide each one of these terms by tangent x. Tangent squared divided by tangent is tangent, and tangent x divided by tangent x is 1. Now we use the zero product property, and we find solutions by setting each factor equal to 0. So tangent x is equal to 0, and tangent x plus 1 is equal to 0. We need to get this tangent by itself by subtracting 1 from both sides. So we get tangent of x is equal to negative 1. Let's go ahead and find where tangent x is equal to 0. We have learned that tangent is the slope of the terminal side on the unit circle. We also know that a slope of 0 is a horizontal line. So the question is, where on the unit circle will we have a slope of 0? Where do we get a terminal side that is horizontal? We see the first horizontal terminal side right at the start. right at 0 radians. So x equals 0 is one solution to this equation. But if we rotate this around, well, maybe I'll leave this one. If we rotate this around until it gets to this position, it is again going to be horizontal. But over here, we are now at pi radians. So x equals 0 and x equals pi are the two angles where we have a horizontal terminal side, thus a slope of 0. So the tangent is equal to 0 at 0 and pi. So now what about the tangent of x is equal to -1? We can find the reference angle by ignoring the negative sign and asking ourselves the tangent of what is equal to 1. We have memorized that the tangent of pi over 4 is 1, so the reference angle is pi over 4. On the interval from 0 to 2 pi, here are the four angles with a reference angle of pi over 4. In this case, we want the tangent to equal -1. Again, tangent is the slope of the terminal side. So we will stick to quadrants 2 and 4, where the slope and thus the tangent will be negative. We can think of pi as 4 pi over 4. So this angle in the second quadrant will be 3 pi over 4. Doubling this, we can think of 2 pi as 8 pi over 4. So this angle in the fourth quadrant is 7 pi over 4. These are the x-coordinates of the four intersection points of f and g on the interval from 0 to 2 pi. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.